Viewers, welcome to our channel. This is a CSIR NET 2019 December session question on real analysis, which says that if X is an infinite countable subset of R that is also bounded, then which of the given four options is true? This we will do by considering a counter example. We let X is equals to closed interval 0 1 intersection the rational numbers. Then of course X is a countable bounded subset of R. We will check the conditions one by one. First, we will check that whether X is compact. We will first state the Heine-Borel theorem. Heine-Borel theorem states that a subset of Rn is compact if and only if it is closed as well as bounded. Our set X is already bounded. We will have to check only whether it is closed or not. Let X be any point of 0 1. Then any neighborhood of X contains infinitely many rational numbers by the density property of rationals. Hence, X is a limit point of capital X. Now, since any point of closed interval 0 1 is a limit point of X, thus any irrational point of closed interval 0 1 would also be a limit point of X, and in that case the irrational numbers does not belong to capital X, and thus since the irrational numbers being a limit point of capital X does not belong to so X can't be closed in this case. Thus option 1 is ruled out. Next we check option 2. Let X be any point of capital X and X minus epsilon X plus epsilon be an epsilon neighborhood of X for any epsilon greater than 0. Since the irrational numbers are dense, so X minus epsilon X plus epsilon contains infinite number of irrationals. and in which case x minus epsilon, x plus epsilon does not wholly belong to the set capital X. This is true for any neighborhood of X. Hence, any point, or rather, hence, no point of capital X can be an interior point of X. Thus, option 2 is also ruled out. For option 4, we check for the closure of X. Since, as we have already seen, any point of closed interval 0, 1 is a limit point of X. So, the closure of is none other than closed interval 0, 1 itself, which is not countable, of course. Thus, option 4 is also ruled out and we are left only with option 3. The case that we have taken here, X is equals to closed interval 0, 1 intersection Q, is not bounded in this case, but here it is said that X may be closed. So our option 3 is the only correct one, and three is our required solution. Thanks for watching.